Hello and welcome to our Let's Build on AWS. Today we will help Richard's startup to create custom solutions and devices using Internet of Things to provide a better experience to their customers, to cool the water, and also to control temperature and humidity with a high precision sensor of the food storage. I am Vinicius Sanger, and today I'm going to present this episode with Ana Cunha, and we both work for a developer relations team. Today we will cover the basics about IoT, AWS IoT Core Services, protocols, and how to prepare your computer so you can start developing for IoT using ESP32. If we look at the internet history, 50 years ago when the internet was born, we had like less than 100 devices connected. So today we have billions of devices, computers, video games, cell phones, smartwatches, and we have a very different types of devices, like even a turtle can be connected to the internet. I live in Ubatuba, Brazil, and they are monitoring, I'm very near from the ocean, they are really monitoring turtles using internet. Helmets, cars, bikes, vacuum cleaner, even a diaper can be connected to the internet, so you can monitor the baby services using your cell phone, for example. One of our customers that we are very proud, and they are really using hard our IoT services, is iRobot. They have more than 2 million vacuum cleaners connected to our cloud. And GoPro, they have the GoPro Plus service that allows customers to upload images and videos straight to AWS Cloud, and it's also an example of connected device. And for sure, we have Alexa and different types of Echo Dots and Echo Show and so on. So it's a voice assistant, and that can even control other IoT devices like heater, lamps, cameras, etc. So it's a very nice example of IoT device. And what I love most about IoT is that you can create your own solutions, just like we are going to do for Richard's startup, food startup. So we will see this video with an amazing project by an AWS co-work, Troy Larson.
My son is 16 years old and he has autism, severe autism, and he's not able to communicate. As a technologist, I have always been looking for different ways to help him communicate. So he can speak certain words and phrases, and he can read and write, but he can't hold a conversation with you. And the idea behind Plexi was to help build technology that could help him and others with dementia or other special needs, to give them that confidence to not have to have someone constantly in their space monitoring them, but sort of an invisible assistant that lets them have that freedom and sense of confidence to live their day-to-day lives. Plexi is connected to a speaker in his room, as well as some lights and some buttons.
Good evening, Calvin. It's time to get ready for bed.
And the lights let him know that there's a message that's speaking, and the button is a way for us to confirm that he's actually listening to the message.
Please push the button.
Typically, with people with autism, they love routine and they work best on routine.
Good morning, Calvin. It's time to brush your teeth.
Okay, now brush your teeth.
And so it gives him a calm, consistent communication on a regular basis. And so it has been a great tool to give him some sense of consistency, which is very important for people with autism. The fact that we have this technology now in Lex and Polly and Alexa, and there's so much momentum behind it at Amazon that provides that support to be able to build a tool like this. I feel encouraged and empowered to actually build this, to build a tool like this for my son. And it's very fulfilling because this is the tool that will reach out to him and break through.
So nice project, yeah? So to work with connected devices, we will use the AWS IoT Core service that provides a messaging management between devices and cloud, and also the management of devices and fleets of devices, including security that is top priority in all kind of projects, right? And that's the screenshot of our console. The messages will be sent over a protocol called MQTT, which is the most popular IoT protocol. It's lightweight, designed to consume few resources like battery, internet connection, and is very fast compared to other protocols like HTTP. And so it's based on publish subscriber architecture, which allows device to send data to multiple subscribers. We can have someone publish data from sensors, and the broker will take care if you have 100, 1,000 of subscribers. Our AWS IoT Core Service is a broker that will send the message to many subscribers without any effort from the device. Okay, but the effort is all from the broker. So we will see a demo using this old AWS IoT button that we are going to build from scratch in the next chapter, in the next episode. So I don't think that we are selling this guy anymore, but now we can do it yourself. It's very easy, very simple. Let me jump to my browser. And then I have here the IoT console. And what I'm going to do here is to show you that I have manage here, I have things here, and you can see here that I have IoT button 2. I just create this guy here. And once you create the thing, you are going to create a certificate, and you can associate with policies with this certificate telling the device what the device can do in our AWS account. So it's very easy to create the thing here, and we need to transfer to download the certificates, upload the certificates to the button, configure the Wi-Fi ID and password, and done. We are ready to use the button. So I already did the setup, and now I'm going to test this guy here, and I'm going to say IoT button /plus. I'm going to subscribe, and let me show you that I'm going to press the button. It will start the microcontroller, and then boom, the message is here, single. You could see that the light was blinking white and green. That means that it succeeds sending the MQTT message to the cloud. Let's do it again. This time, double clicking the button, 1, 2. Boom, we have here double, and we have the battery voltage and the serial number, so we can react differently for each kind of sensor. And now I'm going to show that the final result. We have here the food control sensors. That's from the episode number 3. So that's the final result of this Let's Build on AWS. And now we are reading the temperature and the humidity to control the food storage. And we have the call waiter button. I'm going to press my button here. Boom, I just press it. Device time, device name, and also the table number. So I have my circuit working here. That's the final project. You need to attend the other sessions so you can see everything working. So that's very nice. And then now let's move forward. Let's get back to my slides. And so let's talk about the ESP32 module. This is a very popular and very easy to find in different countries. It's a very nice microcontroller behind. It's a module because it has much more than the microcontroller. It consumes little energy and has Wi-Fi and Bluetooth. It has several ports to connect sensors, such as temperature and humidity that we are going to use. And in addition, it's compatible with Arduino and also compatible with our operating system for IoT called Amazon FreeRTOS. So Arduino, what is Arduino? We recommend to Richard to create his prototypes using Arduino because it's easier to start programming devices with Arduino. ESP32 is one that you can use. You have thousands of libraries to work with sensors that speeds up the development process, and also you have a lot of material on the internet. Arduino is not a device. Arduino is a platform created by Massimo Banzi, and is a complete ecosystem that popularized open source hardware. ESP32 is just one of thousands of devices that can be programmed with Arduino. Amazon FreeRTOS is our professional operating system for IoT. When we want to have a greater control over everything, we want to go to production in a serious way, and you need like real-time execution and real-time control. That's the good guy to use. FreeRTOS is the most famous operating system for real-time, and we created Amazon FreeRTOS based on this project with all these the advantage that already exist on FreeRTOS, and we aggregated like security and updates over the air capabilities. So we are not going to use Amazon FreeRTOS now because it's kind of more complex to do it in 3 episodes. Maybe we can have in the future a new episode. But everything that we are creating here and prototyping with ESP32 and Arduino can be later migrated to Amazon FreeRTOS for you to professionalize your IoT project, right? Another common question is around Arduinos versus computers like Raspberry Pi. Raspberry Pi is a computer running Linux, and it has a lot of capabilities. And Arduino devices, they are bare metal with microcontroller, low energy consumption, limited resources, single app, like we call as firmware, right? And Raspberry Pi can run Linux, you can do AI ML in the edge, you can have multiple apps, multi-threading, and all the benefits from a Linux operating system. So if you have a bigger project and a bigger device, like we have Deep Lens, we have Deep Racer, we have smart cameras in many different scenarios, you can use AWS IoT Greengrass. Greengrass is a service that you can download and install a piece of software from Greengrass in your Raspberry Pi, for example, and then you can download a part of the cloud to your local device, like Lambda functions, Docker containers, trained model, connectors for industry. We are not using Greengrass because we are not using Raspberry Pi. It would be too much for this project. But if we need to do like a smart camera, you may want to choose a Raspberry Pi or a Raspberry Pi-like device. It's very common in tractors, hospital equipment, and even my old Volkswagen van, I own one here, is running Raspberry Pi with Greengrass to collect data from engine and send to the cloud. In addition, Greengrass allows devices to work offline, disconnected from the cloud, and you can store the sensors, and then you can publish the sensors once you have connection again. We have more than 300 industrial devices that you can choose to build your professional projects running Greengrass, and that's the URL to our catalog. And so feel free to check it out and see which one is better for your project. So I hope you have clarified some basic concepts about Arduino, Raspberries, Amazon FreeRTOS, MQTT, but let's get your hands dirty and see how to prepare your computer to start developing with Arduino, ESP32, and AWS IoT Core. And my partner, Ana Cunha, will be helping you on that. Thank you very much, and let's build.
Thank you, Vini. Hello, everyone. I am Ana, and I'm also a developer advocate at AWS. So now it's time to build. we're going to help Richard and Mary get started with IoT on AWS. Now that Vinny has given us an introduction, let's write our first IoT code. The first thing we're going to need for this module is an ESP32 board. You can't quite see it from the picture, but it's actually really small. Let me show you the one that I have right here. Like Vinny mentioned, the ESP32 is very easy to use, affordable, and can be found online. We are also going to need a micro USB cable to connect it to our computer. On the following modules, we're going to need more hardware, but for this first one, these two items should be enough. The sample code used on the 3 modules is available on our GitHub repo and can be accessed on the link or QR code below. So what are we going to build on this module? Whenever we're learning a new programming language, we start by writing a hello world code. This too applies for microcontrollers, but what is the microcontroller equivalent of printing something on the screen? Since we don't have a screen on our microcontroller, this usually consists of blinking an LED light. It is very exciting, and I was super happy when I first wrote my blink code. So let's help Richard and Mary get that same feeling of accomplishment. After writing our first program using the Arduino IDE, we're going to connect our board to the AWS cloud. We're going to do that through AWS IoT Core using the MQTT protocol to send and receive messages to AWS. We need to set up a few things before we can start programming on our ESP32 board. The first one is the Arduino IDE. It's an open source software and it can be downloaded directly from the Arduino website. Then we're going to need to set up ESP32 support for the Arduino IDE. We're going to go to the Arduino IDE preferences and paste the expressive URL on the Additional Boards Manager field. Once we do that, we can go to the Arduino Boards Manager and search for ESP32. We're going to install ESP32 by Expressive Systems. After the installation is complete, we can select the ESP32 dev module from the boards menu. We're going to connect the ESP32 board to our computer through USB, and then we're going to select the USB port on the ports menu. All right, with the ESP32 setup complete, we can write our Hello World program. To do that, we're going to need some information about our board. Like Vinny mentioned, the ESP32 has several general-purpose input-output pins. They can be used to connect the board to different things. Over here, we have the pinout for the board model that I'm currently using. It shows all the board pins and their functions. In order to control the built-in LED, we need to know which pin it is connected to. This is the built-in LED that we're going to control with our code, and it is connected to pin number 2. With that information, let's head back to Arduino IDE and make this LED blink. Whenever we start a new project on Arduino, we get a file with 2 functions. The setup function runs once when the board powers up or resets, and the loop function runs in loop for as long as our board is on. The setup function can be used to initialize pins. So we're going to use the Arduino pin mode function to configure the LED pin as an output. Being an output means we can change its voltage level between high and low. We're going to do that during the loop using the Arduino digital write function. When we set the pin to high, the LED will turn on, and when we set the pin to low, the LED will turn off. We are also going to wait 1 second before changing states so we can get the constant blinking. Now, the only thing missing is assigning the LED pin variable to pin number 2 on our board. Once we are done writing our code, we can compile it to make sure it doesn't have any errors, and then we can upload it to our board. The upload part can take a while, but once the upload is complete, we get to see the LED blinking on our board. You can see right here. This is really exciting. It's very interesting to see the code that we wrote in action on something that we can hold on our hands. So now that we have helped Richard and Mary write their first code, what is next? How can they securely connect their boards to the AWS cloud and leverage multiple AWS services? Like Vinny mentioned earlier, this can be done through AWS IoT Core. So what do we need to be able to connect to AWS? We're going to need to create a security policy that tells what actions our board can perform on AWS. Then we're going to create a thing on the console that will represent our board on the real world. In order to securely connect to the cloud, we're going to create a certificate for the thing, and we're going to attach the security policy to that certificate. Finally, we're going to need to copy the AWS endpoint information so we can use it on our code to connect to AWS. So let's head to the AWS console. On the AWS console, the first thing we need to do is create a policy. We'll call it Let's Build Policy. And this policy will allow the ESP32 board to perform several actions. Connect to AWS IoT, subscribe to a topic, and receive and publish messages. We are going to add a statement for each one of these actions, specifying the resources that we want the board to interact with. After that, we're going to register a thing that will represent the ESP32 board. We'll call it ESP32 and leave the other fields as they are. We're going to need to create a certificate for our thing so that it can securely connect to AWS. Over here, we need to download all these files: the certificate, its public key, and its private key. We're also going to need the Amazon root CA. It will open on a new tab and we can download it from here. Heading back to the AWS IoT console, we're going to activate the certificate and then attach a policy to it. We're going to choose the policy that we have just created. And now we can click on the ESP32 thing, and from the Interact menu, we can copy the URL for the AWS IoT endpoint. This endpoint will be used on our code to connect the ESP32 to AWS. Now that we have finished setting up the ESP32, let's make it talk to AWS. We're going to need a few things on our code. The first one is to install the MQTT library on Arduino IDE. Then we're going to need to copy our certificates to a special file called secrets.h. Like we did before, we're going to compile and run our code. And then we're going to check both the AWS IoT console and the Arduino serial monitor to see that the MQTT messages are being sent between them. Okay, let's go back to the Arduino IDE and make this happen. This is our main file, and we are using Arduino's Wi-Fi client secure to securely connect to AWS. We are also using the MQTT client to send and receive messages between our device and the cloud. But the MQTT client is not included as part of Arduino's libraries, so we're going to have to install it. We're going to go to Tools, Manage Libraries, and search for LWMQTT. With the library installed, let's take a look at our code. We are including the secrets.h file that contains our certificates and private key. These are the files that we have just downloaded. My file is already filled out with Amazon's root CA certificate, my thing certificate, and private key. Yours will look something like this. Please note that this information is private. Your certificate and private key should not be shared with anyone. We are only showing them here for educational purposes, and this certificate will be revoked as soon as we're done with the demo. Going back to the main file, we are defining the name of our thing and also two topics. One that we're going to use to publish information from the device, and the other that the device will subscribe to and receive messages from. On the setup function, we are calling serial begin to send data to Arduino's serial monitor. We are also connecting to the Wi-Fi. The Wi-Fi setup code is on the Wi-Fi file. You just need to configure with your own SSID and password. During the setup, we are also connecting to AWS. The AWS connection code is on the AWS file. Over here, we are using our certificate to safely connect to AWS. We are initializing the MQTT client on the AWS endpoint, and we are connecting to the MQTT broker using our thing name as the client ID. After successfully connecting to AWS, we are subscribing the ESP32 to the subscribe topic and creating a message handler that will print any messages we receive to the serial monitor. Now, on the loop function, we are calling the loop method of the MQTT client. This is responsible for sending and receiving packets, and it should be called on every loop. Finally, the last action on our loop is publishing a message to the publish topic. Now, we're just going to need to compile and upload this code to our ESP32 board. While we're uploading, we can open up the serial monitor to see our code in action. Over here, we can see that we have connected to the local Wi-Fi network and to AWS IoT. So let's head to the IoT console. If we check the activity for our thing, we can see that it has established a connection and it has subscribed to the subscribe topic. We can now use the MQTT test client to check that it's sending and receiving messages. We're going to publish a custom message to the topic which the ESP32 is listening to, which is foodstuff/subscribe. Once we hit publish, we can go back to the Arduino serial monitor where we can see that the ESP32 has received our message. Finally, if we subscribe to the topic in which the ESP32 is publishing messages, we can see that every second or so, a new message is being received by AWS. This is it. We have successfully connected our IoT device to AWS, and we are communicating using the MQTT protocol. I hope you have enjoyed this introduction to IoT, and that you will join us on the next module to see what Richard and Mary are going to build using IoT. Thank you.
Well, hello there, you amazing tech people, you. Listen, thank you so much for stopping by to check out this video. Thank you. However, there is so much more great content out there to be found. So make sure to subscribe to the Build on AWS YouTube channel. And while you're at it, click that bell icon to be notified about the latest and greatest in videos made by builders for